Now you had gone through implementation details of all the submodules in the DUT, and now it's turn to go to the final DUT module, which is the interconnect. So this is the interconnect module. So to this interconnect, you are passing all the clock and reset and all the interfaces, which are two set of AXI interfaces, like AXI address interface 1, 2, data interface 1, AXI write data interface 1, 2, AXI write response interface 1, 2, read address interface 1 and 2, and read data interface 1 and 2, and finally an OCP interface. And you can see that the AXI to OCP conversion part is already taken care by the module, the AXI to OCP converter, and we are just instantiating that module with the dot star, so that all these interface names of the AXI to OCP converter name is exactly same as that is we are passing in the input. So you can see that AXI OCP converter, the port list is exactly matching with these names that we use in the top level module interconnect. So we just need to use a dot star. Also, the conversion of the incoming write request and read request and sending it to the OCP response OCP channel is again handled in this module. So this is a wrapper module for handling all the conversion from AXI to OCP. And to do the conversion from OCP to AXI, which is for the read return path, whenever the masters are requesting a read from the client, the OCP client will respond with the read return, and that data has to be sent to the appropriate AXI masters. And for that part, I have not used another submodule, but as this conversion is quite simple with the submodules, I have directly instantiated the submodules here within the main module. So this is exactly same as that we have shown in the block diagram. So we have a whole AXI to OCP converter and 3 submodules for the OCP to AXI conversion, which is the OCP read return front end and OCP to AXI converter 1 and 2. So the OCP read return front end is instantiated again with the clock reset, the OCP interface, and the output of this module is the OCP read return packet valid and OCP read return packet. So these packet valid and packet, this output packet is sent to the OCP to AXI converter 1 and 2. You can see that the signal is exactly same. So this is output packet driven from the front end OCP read return front end module, and it will be again tied to both modules. Both these modules, the packet will be tied, and only the packet valid information will be changed according to the tag. So we can see that OCP read response packet valid 1 is equal to, whenever the output packet.id is less than 7, it is equal to the packet valid that is coming from the read return front end, otherwise it's 0. In the same way, the packet valid 2 will be equal to whenever equal to 1 or equal to the OCP read return packet valid whenever the output packet is greater than 7. Thus, depending on the ID field of the output packet from this particular module, this packet is routed to the AXI to OCP to AXI converter 1 or 2 accordingly, but always the packet is tied to both modules, and only the valid signal is changed accordingly. One part I have not implemented here is a hold. So ideally you should drive out the hold from these two converters. So you can see that the hold output from these two converters are when the internal FIFO is full, and that hold has to be routed into the AXI read return front end, and again it should be driven into the OCP response ready signal. This is missing here, which need to be implemented. So this complete the module description of the interconnect. Thus you had gone through the complete code of the interconnect with all the submodules and all the block diagrams, and now we will go through a simulation.